We define the singular point into two terms. The first one we call regular singular point, and the second one we call irregular singular point. The way that we use to judge which x value that we call regular or irregular singular point, we are using this criteria. The criteria is saying that x minus x0 times px and x minus x0 squared times qx. If you have any x value which makes these two functions to be a non-analytical function, those x we call it irregular singular point. On the other hand, if the x value makes these two functions to be analytical functions, then those x value we call it the regular singular point. And the way that we are going to find the solution for differential equation while that x, you got to define what is that x. That x is the ordinary point or singular point. If ordinary point, you use the technique that I taught you in the morning to find the solution. But if it is a singular point, you got to check by using this criteria whether that x is a regular singular point or irregular singular point. If it is a regular singular point, then you can use the following method that I am about to teach you to find the solution. Okay. And that technique we call convenience method. Just for your information, if you want to read from the textbook, and those textbooks just mention about convenience. The convenience method is just the method that's using for finding the solution in the series form around the point that we call regular singular point. Okay, so now let's take a look at the example how to start. Oh, square. So I'm going to teach you how to consider the type of the singular point for this equation. We are going to consider whether this equation has singular point. If so, what type of singular point it is? Whether it is a regular singular point or irregular singular point. Okay? In order to do that, we've got to arrange this differential equation. In order to get Px accused x, right? In order to get Px accused x. So from this, we know that our Px is equal to x over x squared minus 1, and our Qx is equal to 3 divided by x squared minus 1. 2, we have like singular point for this problem statement. Do we have singular point? Yes. How many? We have 2. Okay. We have x equal to 1 and minus 1. Both of them are singular points. So the next thing that we got to do is just that tell that x equal to 1 is a regular singular point or irregular singular point and do the same as x equal to minus 1. So then I said that consider x equal to 1 first. Okay, it said that if we want to consider x equal to 1, whether it is a regular singular point or irregular singular point, we've got to check two functions, x minus 1 px, and the other function is x minus 1 square qx. For this one, x minus 1, px is x divided by x square minus 1. So we'll get x minus x plus 1. So here if you put x equal to 1 here, this term, this function x minus 1 times px will be analytical function or non-analytical function. Can we find the value of them if we plug x equal to 1 in this equation? Yes. So that means when you put x equal to 1 there into this one, this function will be analytical function. So that means x equal to 1, let me put it this way, might be a regular singular point. We just can't find it right now because to check this function, x minus 1 squared 2x. Okay? X minus 1 squared times qx is 3 over x squared minus 1, which is equal to x minus 1 times x divided by x plus 1. With this one, if you plug x equal to 1 into this term, we get qx as the analytical function. Can we find the value of this function? Yes, we can. So in that case, we can say that as x equal to 1 is a and yield a regular singular point. We do the same as x equal to 1 with x equal to minus 1.นะคะ3ขอโทษค่ะ So we find x, now x is equal to minus 1, so this one you would get x plus 1, right? Because x minus x0, our x0 is equal to minus 1, minus and minus becomes plus. Px is x divided by x squared minus 1. If we plug x equal minus 1 into this one, we still getting this function as analytical function. Can you find the value if you put x equal to minus 1 in here? Yes. Now we check the second criteria. Do it again. Plug x equal to minus 1 in here. Whether it's still analytical function? Yes, it is, right? So by that we can say that at the point that x equal to minus 1 is a regular singular point. So that means both singular point for this problem statement, x equal to 1 and x equal to minus 1, both of them are regular singular points. So you can find the solution around these 2 points. Again, t square minus t minus 2 square, second derivative, consider the type of singular point for the following differential equation. So we have now our independent variable is x. Is t. With this problem statement is t. Okay. We are going to consider whether this problem has singular points or not. If so, then we get to define what type of singular point that we have. In order to do this, we are going to rearrange our differential equation in such a way that we got pt and qt. Now it changed to t, right? Because our dependent variable is t. So that means our pt is equal to t square minus 4 divided by t square minus t minus 2 square, and our qt is equal to minus t divided by t square minus t minus 2 square. Just make it more simple, t minus 2 and t plus 2, right? And under down here, we got t minus 2 and t plus 1. And they put square for both, right? Okay. This term and this term would the same, just cut it out. So we would get for pt is equal to t plus 2 divided by t minus 2 times t plus 1 squared. And down here we would get minus t divided by t plus 2 squared times t plus 1 squared. Any questions? So, from pt and qt, do we have singular points? Do we have singular points? Any p that makes pt and qt go to infinity. T equal to what? 2 and minus 1. So we have 2 points of p, which is a singular point. T equal to 2 and t equal to minus 1 are singular points. So the next step is just that we find whether t equal to 2 is the regular or irregular singular point, and again define that t equal to minus 1 is the regular or irregular singular point. So to do that, we got to consider each term at a time. Okay? So we consider t is equal to 2 first. We have two criteria. T minus t0 pt and t minus t0 square qt. Right? This is the two functions that we are using for define whether that our singular point is a regular or an irregular singular point. So now our t0 is equal to 2. So we got t minus 2 pt, which is t minus 2, our pt is t plus 2 divided by t minus 2 times t plus 1 squared. So you have t minus 2 the same, you cut it out. So you got t plus 2 divided by t plus 1 squared. So with this one, if you place t equal to 2 in there, can you find the value of this function? Yes, you can. So that means with the first criteria, it seems like t equal to 2 is a regular singular point. But we just can't make a conclusion until we find this term. Okay, now we do the second term, we would get t minus 2 square qt. T is equal to t minus 2 square. Our qt is minus t divided by t minus 2 square times t plus 1 square. You cut it out, you would get minus t divided by t plus 1 square. Again, doing this term, if you plug t is equal to 2 into this function, what would be the value of this function? Can you find the value of this function? Yes, you can. So that means with these two, you can say that t is equal to 2, at t equal to 2 is a regular singular point.